Hello! In this quick video tutorial, I will explain stack versus heap memory management.
Imagine your computer's RAM as a vast, empty plot of land. When a program starts, the operating system divides this land into two distinct territories: the strict and organized stack region and the chaotic and expansive heap region. Territory 1, the stack, operates under strict rules, like a pile of sticky notes. You can only add to or remove from the top, following the last in, first out principle. This organization makes it incredibly fast. When your program begins, the main function is called pushing a stack frame onto the stack. This frame temporarily holds local variables, such as, quote, int x equals 10. If main calls a helper function, we pause main and place a new frame for the helper function right on top. The CPU focuses only on the topmost frame. As soon as the function finishes, its frame is instantly popped and destroyed. This automatic cleanup makes the stack very safe and fast, as we automatically return to the previous function. What about data that is huge or needs to survive after a function returns? Welcome to the heap, a massive warehouse with huge space and random access, but requiring manual management. To use the heap, you must request space using commands like new or malloc, asking the OS to find a spot for your data. The OS finds a free spot in the heap and returns an address or pointer. This address is stored on the stack, allowing the stack frame to reference the heap object. The critical difference is persistence. Heap objects remain available, even as stack frames pop and disappear, until you explicitly delete them. The danger of manual management is a memory leak. If the pointer on the stack is popped before the heap object is deleted, the object becomes orphaned, consuming memory indefinitely. Conversely, the stack has a small limit. If a recursive function calls itself endlessly, the stack will overflow, leading to a program crash. In summary, the stack offers automatic, very fast memory with a small size limit, where variables die quickly. The heap is manually managed, slower, but offers limitless space and persistent variables.